Something's gotta change. Oh, hey, I was wondering where this went. Oh, right.
Where's Tom Berry? He's never late.
I know. I'm actually,
I can call him.
I'm gonna text him. That's weird.
Tell him the whole class is waiting for him.
Pressure is on.
So we met with
Okay, we're gonna get started. It's time to start. All right, so today we're gonna go into exponential functions. Raise your hand if you know what an exponential function looks like. I got two, sorta.
That.
New seats, new seats, new seats. Find your name, it's real big. Okay. Exponential functions are getting you ready for that 142 class, that 151 class. That's what you're going to be playing with a lot. So for this week, I'm sort of giving you a little intro so that when you walk in the class and they sort of assume you know what it's all about, you know, at least you've had the intro and you'll be okay. But it's real important that this week you come to class, this week you understand it. This week you have really, really good notes. And I'm telling you, when I do the homework, I have to have the notes next to me because this material I don't use when I go to the Fry's grocery store.
Okay.
This is for really, really, really very intelligent people that have invented and done a lot of stuff. You're getting into more advanced math now, which is where you gotta go in order to get your college degree. So it's very, very important you listen and you take really, really good notes. So I've given you my last packet. This last packet, out of any of them, you wanna keep when you go to your next class. Don't throw this one away, because this is where they're gonna pick up with, okay? All right, so again, every semester I'll have kids email me the last day of class, you know, an hour before the exam saying, can I pass this class? And I just don't do that. You gotta sit and be here today and I'll tell you exactly how to figure out whether you can pass the class or not. Take out the blue sheet that's on your desk with your name on the back and your new seat number. And you will notice, look, you will notice that I have filled in a number right here that says your now points. Those are your points that you had this morning when I looked at your D2L class and it told me your grade. So we're going to figure out your worst grade possible first. In this class, you have 100 points left to earn for a final. You have 3 homework assignments left to do tonight, Wednesday, and next Monday. On time, not late. It's a one-shot deal. You got to start getting used to being in a higher level class. So if you don't hand it in on Wednesday, it's a 0 and it stays a 0. You're choosing your grade right now. Okay? So we have 15 points left for homework. You get 5 points every time you do an assignment for me. We have 2 quizzes left. Wednesday you're going to have a quiz. We have a practice quiz today. And then next Monday you have a quiz and you'll have a practice quiz to study on Wednesday for that. So there's 20 points left to earn for quizzes and then what we call bonus points, and I'll explain that in a minute. Take your points, this number that's right here, and look down below in this red box. And if you decide to be a vegetable and do nothing from now until the final exam, except put your name on the final exam and then leave, whatever points that are up here, write that number of points right there.
You told me he's here.
Okay, now look at the chart and see what category those points are in. And that's your grade if you decide to be a vegetable. In other words, do nothing from now until the end of the semester, whatever points you've earned right now. Suzanne, can I use you again as an example? Okay, what's your points now again? 530 something? 583. So she has 583 points, so she's gonna come down here and write the same number. And right now, she's got a C in the class if she decides not to do any homework, not to do any quizzes, and just put her name on the final and leave the room. Not a good idea if she's going into an upper level course, but that's a choice she can make. All right. Everybody got your worst grade possible done? Just looking at this point, this number, and finding it below, that's the grade you got if you decide to do nothing. Now we're gonna do Utopia Land. So I'm gonna use Suzanne's grade, and I have 583, or 583 for her. She's gonna do the final practice 10 times. And I promise you that if you actually do the final 10 times, you can get 100 on my final. Because the problems are identical, all I do is change the digit. So if you practice something 10 times, trust me, you're gonna get 100 on that final. So 100 is possible for everybody in the room, but you gotta practice. I couldn't get 100 on the final if I didn't practice. And I wrote the darn thing. Okay, I'm gonna do the 3 last homework assignments the night it's assigned. I'm gonna email me, I'm gonna have a study group, I'm gonna go to tutoring. By gosh, oh golly, I'm gonna understand those 15 to 20 problems on every one of those 3 assignments. And I'm gonna hand them in on time, 15 points. Okay, next Wednesday I'm gonna come in and I've done the practice quiz, you know, or 10 times if you want a 10 out of 10. I've done it, I've gone to tutoring, I've done something, I've done study groups, I don't care what you do. I emailed the instructor on the one I didn't know how to do. I looked at my notes, whatever. I got 20 points for both Wednesday's quiz and next Monday's quiz going over logarithms.
Over what?
Logs.
Oh.
All right, so now I have to figure out my bonus points. Bonus points are extra credit that I'm going to give everybody in this room. Everybody's going to get some extra credit if your final is a 75% or above. If your final isn't a 75% or above, you're not going to get any bonus points. Right here, listen. All right, so we're going to take Suzanne's number again, 583. What number do you have over here in the circle on the right-hand side of your blue sheet? I can't remember. No, that's your now. I want to know there's a circle on the right side of your blue sheet at the top that says what exam was your lowest exam? 83. So she's got number, was it number 3? Number 3, her lowest exam was an 82 so far this semester. Now, in the olden days, I used to say, go find your lowest exam, and it took everybody half an hour. What did I do? I went and looked on your individual D2L assessment, and I found everybody's lowest exam. And I put down there which exam it was and what your lowest score was. Now, exam 1 and exam 2 were higher than her 82. So I'm not gonna mess with the higher ones, I'm only gonna mess with the lower ones. So her lowest exam is an 82, so I'm gonna do 82. And then I'm going to figure out the bonus points. So now what do you think you're gonna get on your final? Do you get 100 on every final? And you can put 100 here. If you say, ooh, I hope I get 100, that's this column, don't do that. I only have 2 people in this room that get 100 on exams. And I know those 2 people go over the review sheet at least 10 times. I got 2 people in here that have almost 770 points. And I know they work their butt off. It could be any one of you that I'm looking at. You got that? You know how hard you work. So, what's your realistic grade? Do you get 100 on most of the exams? No. We all make stupid mistakes. So what grade do you think you can get on the exam? 93. So she's saying she usually gets in the 90s. She's going to go study, work her butt off, and do the practice exam that you can find in next Monday's D2L lesson. It's lesson 31. You can click on it and you can print off 10 of them and do 10 of them yourself. So that next Monday when we come for practice and you're around the room, you're gonna know how to do those 20 questions instead of looking around the room like we did on that exam 3. You gotta start now. You don't start next Monday night to study for this exam. All right, so she thinks she can get a 93. Do you do your homework every day? So I know she does. She sits after here until she's got it perfect. So I know she does. She gets 15 points. You get 10 out of 10 on every quiz. She does. Do you do the practice quiz? A lot. So I'm going to give her 20 points because she's going to work her butt off for the next 2 practice quizzes. Now, her bonus points. She got a 93, let's say, on her final. So we're going to take what you think you can get on the final, subtract what's in that circle on the top right-hand side where it says either number 1, number 2, or number 3 in your lowest score. So her lowest score was an 80, is it 82? 83? How do I get rid of this?
I click the bottom.
With the bottom.
Yeah.
Oh, I love you guys. I was on the phone for 2.5 hours with Apple Computer last night.
Fair enough.
I love smart people that can solve problems quickly. Okay, so we're gonna subtract, so she's gonna get 10 bonus points. Now look, let's say my lowest exam is a 10%. There's somebody in this room that has a percent on their last exam or exam 2 or exam 1, I can't remember, that they have lower than a 10 here, but I'm just using 10. What they'll get is 90 bonus points if they get 100 on the final. Now, will I think they get 100 on the final? Not unless they do that practice exam at least 10 times. They could. But that person's going to get 90 bonus points. Suzanne's sitting there saying, I'm only getting 10, I'm pissed. Yeah, she should be. But you know what? She's worked her butt off all semester and she's already in the C range going into the final, whereas this person is in the F range. They need a lot of help, but are they going to get that 100 on the final? I don't know. Not unless you decide to work your butt off and you don't want to repeat this class. And everybody in the room can do that. Okay, so she gets hit. Now she's going to take the calculator and add up 93 plus 15 plus 20 plus 10 plus her 583. Add up all those and see where she's at, and where are you? 7 something? She gets an A. Don't email me and say, what can I pass the grade? I'm gonna say, go look at the blue half sheet. This is the very best score you can get, the very worst score you can get. And if you're honest with yourself, if you don't hand in the homework, don't give yourself 15 points. Because unless a big bird hits you on the head, you're still not gonna do it the last week of school. Unless you change your mindset. What we learned in 92, what we did in the 92 class. You gotta change the mindset in order to change these grades. And everybody, I'm not mad, everybody in the room can do it. Everybody in the room has a bad exam. Everybody in the room has a bad, paper that I turned in and I got an F on it. I've never had an F on a paper. But I did, but I never did after that one, because I learned what I had to do. It's called the dictionary for me. For you, it's some kind of math help. Question? Everybody have it? We okay? All right, so now let's go to your packet. New packet, white packet. That's the pink sheet, go to the packet. Okay, it's pretty thin. Again, I made this one just specially for your 151 class. I would keep all your packets. It's a nice little review if you have a brain memory loss, whatever. You can always go back to this class and learn how to do exponents or whatever. But today we're going into what's called an exponential function. Circle this word right here. What is an exponential function? You're going, I'll never use this any day in my life. Yes, you will. A lot. It's real important. Look at this. The f of x, remember that's function talk. You're going to be doing function talk for all of 152. What I did in my class, was I made that a y equals, but f of x just is the name of a rule. And it says you're going to put in x, but what's different about this new rule?
Decimal.
We've had decimals, yeah.
The x is an exponent.
Yeah, the x is the exponent. And it's like, oh yeah. When I first started teaching, it's like, oh yeah, I forgot that. Yeah, that is. The x has always been, look, like this. We've had x squared plus 2x plus 5, right? And I told you to factor it, x-men, all that kind of stuff. The x has always been the big guy. What are you going to be studying in the 152? The x is going to be the little guy now. Woo. When the heck do you ever use that? Every day. All right. So what I've given you is some examples of what an exponential function looks like. All of these in the black, red, blue, and green boxes are called exponential functions. They can be very simple to very complex. Look at that. Ooh. Okay? What you need to do is you need to learn what's the base now of these functions, because next class we're going to need to know what base is really bad. The base is the big number, b and b. Can you remember that? So what's the base of the first black box? 2. Base of the second box? 3. Blue. And a half. Each of these functions have what's called a constant base. It's a number and a variable exponent. What is not an exponential function is what we've been studying this whole exam 2, exam 3. That's not an exponential function. That was a parabola. Remember that? It was a polynomial. All right. Exponential functions cannot have a base that's a 1. Never. Exponential functions can never have a base that is negative. It must be positive. So circle that or highlight it. And an exponential function cannot have a base that's a variable, what we just got over, and an exponent is a variable. That can't ever happen. Now, what numbers, domain, what numbers can you put in for this little x here? It can be any number. You want to write that down. You can put in any number for the x, but the range, your answer, will always be 0 or bigger. I'll explain why in a minute. Okay, are you understanding what an exponential function is? It's got a variable as a little guy, and the big guy has to be a number. Okay. B has to be a positive number. And x can be any number your little heart wants to. Now I'm going to show you, this is, I've taught 50-some years. So I went back into my lectures, and I want to show you what I teach in Illinois. I've been out here 18 years, so this is in the early 2000s, before FedEx and all your delivery people are so popular now. And do you guys ever remember what a shopping mall is? Raise your hand if you were at the shopping mall this week. 2. If I would have said that, 3 of you, if I said that, 20 years ago, how many would raise their hand?
Half.
Everybody.
Everybody. Why? Because they put movie theaters there, they put restaurants in there, and they put every store known to man for any of your needs, and that's where you went to have your little entertainment. Now where are you going? But I wanted to show you, this is the lesson, how I started my lesson in the early 2000s. What is the average amount of money spent in a shopping mall to the nearest dollar if they can keep you in that mall for 3 hours? You're going right now, who cares? I never go to a mall. But this was really, really important. That's why they brought in movie theaters, bowling alleys, anything, McDonald's. Remember when McDonald's, so you guys are all too young, came into the mall, it was like, whoa, I don't have to go to McDonald's. Everything was in that mall. Why? Because they wanted to get you in there and they wanted to keep you in there because of this formula. They surveyed people, everybody that came into the mall for years and years and years and years. And they found out that if they can keep you in there at least 1 hour, you're going to spend about $42 on clothes, food, movies, games, arcades, whatever they're putting into that joint. Now you go over to Tucson Mall and the parking lot's empty. That scares me for them. I mean, what are they doing? What's happening? Stores are closing. So is this affecting your life? Yeah, it is. But this was a formula that they made. And you're going to ask me, how'd they get that formula? They did a lot of data collecting, and then from the data collecting, they made this formula, and that's what you learn in your calc class and your trig class, not in my class. My class, we do linear. Pick your best store, you know, that kind of stuff. All right,
Will this be on the
so
final?
here is the formula for how much you're gonna spend at the mall. Now, the first objective for today is, can you do a exponential function with your calculator? So the question is, if I stay in the mall 3 hours and X represents my hours, how much money will a person spend in the mall in 2000, way back when? Try your calculator and see if you can plug it in. 42.2 times 1.56 to the third power, press enter and round your answer to the nearest dollar.
$160. Oh, no.
160 bucks. So why did they bring movies in there? Because mom and dad will go shopping while their kid watches the Disney movie, or the whole family goes to the Disney movie and the kid screams, "I'm hungry," so they have restaurants in there. And that's how those shopping malls got to be so popular. And they knew that they could get your money if they'd get you in there and they'd keep you in there. And the formula that said that was this exponential function. Now you're going, well, that's in 2000, this is 2024, it doesn't affect me anymore. Raise your hand if you've ever been on medicine from a doctor. Since my stroke. Okay, we've all been on some kind of medicine. That medicine that they put into your body, and they told you to take 10 pills, 20 pills, whatever, is an exponential formula, because they know how long that medicine will stay in your body by doing blood work on zillions of people, and how long it takes for that medicine to leave your body. And that's why they say, take your medicine for 10 days, take your medicine for 5 days, whatever amount of time it is. It's an exponential growth as you're building your medicine in your body. And then once you stop taking it, it's a exponential decline in your body until you feel better. This part of the math world is so important to your everyday life. Raise your hand if you've ever put your money in a bank. Okay, everybody's done that. Why didn't you put it underneath your mattress?
Liability.
Liability. Somebody's gonna rob my house, right? Something's gonna happen. If I put money underneath my mattress 20 years from now, it's gonna be the same amount of money. It might not buy as much, but it's gonna be the same amount of money. When we put our money in the bank, it grows exponentially. That's what we're doing, exponential functions. Every banking system is doing what I'm going to teach you today. And I'll show you that in a minute with the pink sheet. All right, so what they have to do is they have to graph these. And this slide and the next one I keep right next to me when I do the homework, because I can't remember all this. I'm not a scientist, I'm not an economic person. I don't know all this stuff. So if you asked me to do it, I would have these steps sitting right next to me while I do the homework. I would also have some of this stuff on my note card when I do my exam, so that I remember how to graph an exponential function. Okay, the graphs of an exponential function always go through the point 0, 1. Why? Look, if I have 2 to the x power and I make x 0, what's 2 to the 0 equal? We learned that in exam 2. 1. Let's say my formula says the f of x equals 5 to the x power. What's 5 to the 0 power? 1. Anytime I put in a 0 and my exponent is a variable, I'm always going to get a 1. So all your graphs, when it's of this form, where you just have a base to the exponent of an x, will always go through the point 0, 1. Now, when I was tutoring my son when he was in high school and he didn't have a teacher that explained it very well, he didn't get what the graph of an exponential function was. So he was a Nike kid. You guys know the Nike swoosh? I said, an exponential function is basically a Nike swoosh. It's got a low end and then it's got a high top to it. So Nike sort of stole an exponential graph. All right, so what your graph is going to look like, it's going to start low and then it's going to go up like that. You see, when you start taking your medicine, you're sick, you're sick, you're sick, and then all of a sudden, what, 3 days in, what happens? Oh, I'm feeling better. That's that growth. Then when you stop taking your medicine, your exponential function was real high with the medicine, and then as you stop taking the medicine, after a while you don't have any of the medicine left in you. Does that make sense, Gene? Medicine is a great big deal. You know, boy, when I was teaching this during the COVID, whew, this was a great lesson. We went over a lot of neat things about that. But that's what they were doing. They were seeing a big growth in deaths or a big growth in people feeling better, whether you believe for the vaccine or not. You know, we saw graphs like this all the time. Oh my gosh, we got to get some kind of medicine. Everybody's dying. Oh my gosh, the medicine is working or the medicine isn't working, that kind of thing. Okay? Yeah.
What is the exponent? Say to the 2
Number 2.
or
The graph of all exponential functions passes through the point 0, 1. The y-intercept is 1.
The one that you wrote.
Yes, 1.
Oh, this one?
Yeah.
Oh, it's a 0.
Oh.
Yeah, sorry. Okay, exponential functions, listen carefully. The base can only be one of 2 scenarios. Put stars by these. The base stands for big number, has to be greater than 1, or, write this in, a fraction. Those are your 2 choices for exponential functions. The base can be a 2, 3, 4, a million, a jillion. It can be a 2.5, it can have decimals, it can have fractions, but it has to be greater than 1, or it has to be a fraction. Now, what we have to do is draw like a fence. Living in Arizona here, everybody's got fences around their houses, right?
Got what?
Fences. At least in my neighborhood, everybody's backyard is in a fence. In Illinois, nobody had fences. We didn't have fences in Illinois. I had to get shock collars for my dog. But anyway, everybody here has fences. So when we draw an exponential function, we need a fence, a boundary where that we know that Nike swoosh is not going to go lower. That fence is called an asymptote. Say the word.
Asymptote.
Ass.
Ass.
Good. Some.
Some.
Tote.
Total.
Now say it again.
Asymptote.
Do it again.
Asymptote.
Do it one more, everybody.
Asymptote.
Y'all like the first word. All right, so we all have an asymptote. Asymptote is a dotted line, and it's like the fence. Your Nike swoosh will not go below that, ever. And I'm going to show you how to get this asymptote. So when I ask you to graph an exponential function, you have to have your fence, and then you have to have a Nike swoosh. All right, so now how do we do that? Here we go. Here is my math problem. I would have these 3 steps on my note card when you take your exam or your final. If the final has graph and exponential function, I'd have these rules down there. When you go to the 151 class or the 142, this is to help you remember. Okay, every equation is going to have a base with the exponent with an x, correct? That's your exponential. That means we're talking about a Nike swoosh, not a line, not a parabola. It's a Nike swoosh. Everybody okay with that? All right. So what you want to do is you want to look beyond the base and the exponent and see what number is being added or subtracted. If you don't see a number being added or subtracted, it's always +0.
To the exponent, right?
Right here, I'm talking about my K. So the first thing we're going to do is put in a fence around our Nike swoosh. So I want to look at this equation here, and this is the fence. Called, what is it called?
Asymptote.
3 parts. What's the first part?
Asymptote.
Good. Okay. The more you say it, how many times do we have to say it?
7 times.
There's 7. Okay. The more you say it, you're going to remember it. So on your next quiz, if I say, what's the asymptote, or draw the asymptote, you're not going to look and go, what's that? Okay? All right. So I look and I see what number is being added or subtracted onto my rule or my equation. And whatever number this is, that's your asymptote. That's your fence. And you do it with the dotted line. That's the boundary that this Nike swoosh will never go below, ever. All right, everybody okay with that piece? You use your eyes and you see what number is being added or subtracted. So if it said -6, your asymptote would be way down here. This is y equals 6. Okay? If it says 50, you go up to 50 and you draw your fence. It's just telling you where your Nike house is going to be built.
Did you just put that
Always above
-6
it.
there?
Yes.
Can you reiterate? I'm sorry.
I said if it said -6 instead
Oh,
of
that
a
was an example.
+1, then your asymptote would be down at -6. And your Nike swoosh is going to kiss that asymptote. The lowest part of the Nike swoosh is going to be right by that asymptote. It helps you graph. All right, so part 2, create a table of your exponent. So create a table of the exponent is what I would have said if I was going to write a math book. So I look at my exponent up here, x minus 2. Do you see the exponent? It's not a plain x, it has an x minus 2. All right, so I'm going to take the x minus 2 and put it equal to 0 and solve. We're back to the first day of class. You're going, why did I spend the last 14 weeks of your life if the world is built on exponential functions? Because you're always going to go back to the first day of my class. No matter what course you're going to be in, they're going to take you back to the x minus 2 equals 0. What are you going to do to solve for x? Add 2 to both sides, what do you get?
X equals 2.
Okay, so we get x equals 2. And so now you're going to build a chart around x equals 2. What does that mean? Well, you start a chart and you draw some lines and you do 2, and then I do 2 whole numbers less and 2 whole numbers more. So again, if my exponent up here, let's say was x minus 4, you know, let's say it said 2 to the x minus 4, I put x minus 4 equal to 0, solve, what do you get? X equals 4. So I would start my chart not at 2 here, I'd start at 4 and do 3, 2, and 5, and 6. So this part 2, where you take your exponent and you put it equal to 0, is to help you build the chart to get some points to build your Nike swoosh.
Did,
Okay, once I got my number here 2, now I'm going to go back into this equation and put what's 2 minus 2?
Zero.
0. What's anything to the 0 power?
One.
1. But I gotta add another 1 to it, because that's what the formula says. What do you get? What's
Two.
1 plus 1? 2. That's what I got here. Now, what you are finding is where the Nike swoosh is starting to go up or starting to go down. That's the pivotal point. That's right here. The pivotal point where you see how it's starting to spike up. That's where your medicines will start working in. You'll be richer if you're at the bank. And over here is where it's going to start hugging that wall, but will never go below the wall. All right, so I go and put in 1. What's 1 minus 2? Neg 1, right?
so negative
What's
3?
3 to the neg 1 power? 1/3.
Oh,
What's 1/3 plus 1?
every time I say something.
1 1/3. You gotta know your rules of exponents, right? Okay, if I put in x is 0, what's 0 minus 2? Neg 2. What's 3 to the neg 2 power? 1 over 3 to the positive 2 power, which is 1/9. That's what we did in exam 2. So now I have 1 and 1/9. Now can we find those? No, once I get this one, I just have my Nike swoosh kiss the asymptote line. But now I go to the other side and I put in 3. What's 3 take away 2? 1. 3 to the 1 is 3, plus 1 is 4. So when x is 3, y is 4. That's the second point over here. Then I put in y is 4. 4 take away 2 is 2. 3 to the 2 is 9, plus 1 gives me 10. That's this point. And you build your Nike swoosh. You have to build your table, but you have to know where to start the table. And the clue is to create a table centered around whatever you get when you put your variable or your exponent equal to 0 and solve.
Okay.
All right, now listen carefully. I'm showing you 2 graphs. The yellow one is a base of 3. Do you see that? And it's got an exponent of x. I know because there's no other numbers with the variable and there's no numbers being added or subtracted. I know it's going to go through 0, 1. Because 3 to the 0 power is 1, right? Anything to the 0 power is 1. So when it's just a base with a single variable, I know that my swoosh is going to go through the 0, 1 point.
Just like a linear.
But now your swoosh could go down. That's not Nike. Or it could go up. That's how Nike decided to make their logo, right? You don't see the swoosh going the other way, do we? In your shoes or shirts or whatever.
If you don't pay enough.
All right, so when you have a negative variable, your swish will be backwards. When you have a positive variable, x, it'll be a Nike swoosh. Now watch. Here is my first exponential function. I have a base of 2. It's to an exponent of x. That's positive. So I know both of these are going to look like this, the Nike swoosh. I know it, because I've done this for many years. You don't, so you're going to use your notes. You should be writing in your notes to help you remember this. Positive exponents mean that it's going to be a Nike swoosh. Okay, but what's the difference between this equation and this one? They both have 2 to the x, but what else is being added? A plus 3 to one of them. Well, what does that do to the Nike swoosh? It just moves your swoosh up from your asymptote 3 spots. So if you want the Nike swoosh to be at 12, what should I add?
3.
Huh?
3.
Yeah. Oh, not 3. Not if I want to be up here at 12. If I want my
You add
Nike
12.
swoosh to be here,
You're at 9.
I'd have to add 11. 11, because x to the 0 is going to be a 1, and then plus 11 would make it at 12. Oh. This is hard if you've never seen it before, or if you have seen it before, but it's been 20 years for some of you since you've had it. Then you're going to need your notes to refresh your brain and see what you do, and then you got to practice this. So we're going to practice one. So now I want you to look at this equation. Before you start building your Nike swoosh, you need your asymptote line. So on your paper, how do you get the asymptote line? I'm always looking to see what number is being added or subtracted at the end of my exponent term. So I'm adding stuff in your notes. See, go to your notes, and you don't have all this stuff in your notes. So the first thing you want to write here is you want to make this equation so that it has a digit being added or subtracted. It doesn't, so you have to put in a plus 0. You have to remember to put in a plus 0.
There's an implied 0. It's
Yes,
not
if you don't see a number, it's an implied 0. If on your homework it says plus 5, then you're going to use the 5. But I see this, and so immediately I go down and I put my asymptote at y equals 0. All of those points have a y equals 0. That's your fence. This Nike swoosh is not going to go below that green fence. Now I've got to get my chart going. Step 1 in your chart, or the chart, is to take this and put it equal to 0 and solve. X equals 0. What does x equal?
1.
Oh, what does x equal? 0, right? It says x equals 0. So what does x equal? 0. I didn't say what is the equation equal
Right.
to. I said what is x equal to? X is 0. If it's set up here that you had an x minus 5, then you would put the x minus 5 equals 0. It doesn't say that. It says just an x. So step 1 to build the chart, I take the exponent and put it equals 0. Write some notes on your paper if what I showed you doesn't make sense. or what you gotta do, cause it's hard when you're by yourself. You gotta take notes. When you go to the 151 or 152, 151 class, whatever it is, they're not gonna give you a packet like I do. They're gonna give you examples, and then you gotta build your own notes. So I've sort of spoiled you a little bit this semester, but you gotta start adding to my notes to make it make your sense. All right, so in my chart, I only do 2 above and 2 below that number. You know, they're just saying you can pick as many numbers as you want. But from this x equals 0, this is an important thing, 0, I'm gonna put a 1 and a 2, and then I go -1, -2. And then what you have to do is you've gotta put these values in to that equation. So 2 to the 0 power equals a 1. That's the work you would have on your paper, don't you agree? If x is 1, I always do down first. If x is 1, what's 2 to the 1? 2. If x is 2, what's 2 to the 2?
Oh, it changes X, good. Good,
4.
that's good.
Now, when you go to the negative side, 2 to the -1, remember we did this in exam 2, that's 1 over 2 to the +1, which is a half. Now, do you have to graph these little fraction ones? No, you just sort of estimate, and then you play dot to dot after you've connected them, and there's your Nike swoosh. That's how they determine how many days it's going to take the medicine to kick in, how many, years it's gonna take for you to become a millionaire. We okay? All right, we're gonna go to the next piece, and this piece is sort of easy. You need to have out on your desk that little, it's the other blue half sheet that has the x, 2 to the 1, 2 to the 2, 2 to the 3. Do you have that with you? Yes or no?
Did you hand it in today? Did you give it to us today?
No, I've given it to you in the
Yellow.
exam. Is it yellow? Where it
Yeah,
says
okay.
the, 2 to the 1, 2 to the 2, 2 to the 3, and then 2, cube, and 4th power and all that. Yay, Alex has it. Yay. Yellow sheet. Looks like you chewed it, but it's good. You want to keep that. You don't want to throw it away, and you don't want to eat it, and you don't want to use it for kitty litter paper. It's sort of important. It makes your life a lot easier. Okay, your job,
Is it this one?
yes, this one's nice. See, it's not chewed, not eaten, not sat on. This is a good one. Okay. Okay, we all good? You don't have it with you? Does somebody in your group have it with you? No. Okay. So when you solve these exponential equations mean that Mr. X is on top. And you gotta tell me X's value. So this is what you're going to do to solve, show me work, because I'm not gonna give you these easy ones, I'm gonna give you harder ones. If the bases are the same, your exponents will be equal. Do you agree? If I say 2 to the 3 equals 2 to the 3, are the exponents equal if the bases are equal? Yeah. All right, now, let's look at my first example. Do you see my base is 2 and I have an exponent of an x? That means it's exponential. I gotta solve it this new way now. Okay, I'm gonna solve it the new way. What's the new way? Well, in exam 2 and exam 1, you put the x equal to something and solve blah, blah, blah. This isn't the same. So the first step is you gotta get like bases. Do you see how my colors aren't the same? One's yellow, one's pink. They both have to be yellow in order to solve. So now look at your little yellow sheet. Look at your yellow sheet. And you want to look over that yellow sheet and see if you can find any perfect squares. The top row is 8, or perfect cubes where the top row is 8, or perfect fourth powers where the top row is 8, or perfect fifths. They won't take you any lower than fifths. You see 8 anywhere? What is it?
2.
2. So it means I can change the number 8 to have a base of a 2. So what's the base of 2? Look on your sheet.
8.
It's a cube, right? Cube
Cube.
means it's what power?
Three.
Cube means 3.
Power 3.
What does square mean? 2. What does fourth power mean?
4.
What does fifth power mean?
5.
So what you're going to do is you're going to look for this number 8 all through your yellow sheet, and then you're going to look at the title, not the number below it. The number below it tells you what the base is. So the base is a 2, and because it's a cube, now do you see how you have your bases are both the same color? Yay! This is the only way you can solve exponential functions until you learn logarithms this Wednesday. There's only 2 ways to solve these equations. Exponential functions, what we're doing right now, keep them both with exponential functions, and then logarithms is on Wednesday. Once you have like bases, you take your exponents and put them equal to each other and solve if you need to. So x is 3. Don't you agree that 2 to the third is another name for 8? Use your calculator and check if you want. It's not hard. This part is sort of easy. Okay, this one here, I want you to go and I want you to look at 9 and 27. Look on your yellow sheet, find 9, find 27. Do you see them on there? 9 is what?
Square.
3 squared. What is 27?
3 cubed.
3 cubed. Are they like bases?
Yes.
Yes.
Okay, do you see how I wrote it? Write that on your notes. I changed the 9 into 3 squared. I changed the 27 into 3 cubed. Now we have like bases. They both have a 3. Yay! That means we're solving. Now I multiply the 2 times the 2x, because there was a 2x up there, and I brought another 2 up there, so you multiply. I got my 4x, so that's in your notes. Did you see that? You might want to write yourself a little note that says multiply, in case you don't know. And the 27 is 3 cubed, but I have to multiply it by a sum, so that means you got to do distributive property, what we did the first day of class. We're back to the first day of class. The hardest part is to get our like bases. And you're going, what happens if I can't find it? Then you'd say it's not solvable. But am I going to give you a problem that's not solvable? No. It just means you're not finding the right base that's the same for both numbers. Okay, once we have this and we distributed, like I went over the first day of class, we solve for Mr. X. Are we back to the first day of class?
Yes.
Okay, and we get x is 6. That's the solution for x.
You just distributed the exponent into the parentheses?
The 3, yes. This is hard, but when you solve an exponential function, you want to make sure that the big guys are exactly the same on the left side and the right side and the equal sign. Okay, now you try.
See how we still got 6 there.
Number 1, I got a 5, and I can't break 5 down anymore, so I know that that's my green light. That's what I want both sides to have, because 5 can't, there's no other factors besides 5 and 1, so this is still called an easy problem. So I have 5 to the 2x. Now I'm going to look over on the other side, and since this has a base of 5, will 5 go into 125? Okay, now I'm gonna go look on my sheet there, and do I see 125?
Yep.
Okay, what is it, a square, a cube, a fourth power, a fifth power? It's a cube root. So this needs to be a cube root of 5. Because 5 times 5 is 25, times another 25, or another 5 is 125. You can always check to see if you get that pink number. If you don't, you know you got it wrong if you calculate it. Now, do I have same big bases? Put your exponents equal to each other and solve. From this line on, you're just playing with the exponents. And again, it should be what we did the first day of class. Again, the hardest part is to get the same color of the bases on both sides. Now, number 2 is a hard problem. Why is it a hard problem? Because you want to change 8 into a 4, don't you? I would have. But if you look, I can't do 8 as an exponent with a base of a 4. Like this is 4 times a big 2. You don't want to do that. We want to have a base with an exponent. So now go look on your little half sheet and find 8. Where is 8? Is it a square, a cube, a fourth, or a fifth?
Cube.
It's a cube. So I take this one first because it's all by itself. It doesn't have any fancy exponents. And so I know that that's 2 to the 3rd power. Now I go over to Mr. 4 and I say, can I change 4 to have a base of a 2 with an exponent? Let's look at the top row. Do you see a 4 there?
Yep.
Okay, so it's a square. So this is 2 to the 2nd power. Again, it has that x minus 5 outside of it. You're going to multiply those exponent things together. Again, this line, now you take a deep breath and you go, I'm back to the first day of class. All I got to do is put my exponents equal to each other. Show me the work. Two x minus 10 equals 3. Add your 10, divide by 2, leave your answer as an improper, or you can change it to mixed if you want. We don't change it to mixed, we leave them improper as long as they're reduced to those terms. Okay, the hardest problem you're going to have for homework, and again, I'm showing you my work. Yeah, you can hand in your homework and you can copy all the answers I give you. Again, it's not going to help you on the exam to get 100% if that's your goal. You got to really do the homework. I'm showing you what your work should look like. It is a lot of visual with the eye, but I need to see this look-alike step. Don't just look at the problem and say, oh, the answer is 6, and say, I did it in my head. No, we're not doing that. And you're not gonna get 100 on your exam or 100 on the next 2 quizzes doing that. You gotta practice getting this 2 of the same colors. So I see 2 to the x plus 1. Now, 2 can't be broken down anymore. So I need the other guy to be a 2. You're going, oh my gosh, it's a fraction. What can I do first for my work?
Negative.
I could change it to a negative, right? So I could change this to what?
Negative.
16 to the neg 1, right?
Okay, yeah.
Remember, when we have negative exponent, it's assuming you've done your exam 2 and your exam 3. Negative exponents means you have a fraction. Do you remember that? Okay, so I've got this as a 16 to the neg 2. Now look at your list. Did you see 16 anywhere?
Yes.
What is it?
4.
It's a 4th power. Look on your yellow sheet, look on the chewed yellow sheet. 16 is a 4th power, so I can write this as 2 to the what?
Negative 4.
4 times neg 1, which is 2 to the neg 4. Anytime you have a fraction, and you go, gee, I wish it was, upside down, you just make it have an exponent that's negative. You might want to write that in your notes. That's sort of important. Now I have 2 to the 4 times neg 1 gives me 2 to the neg 4. Do I have like bases? Okay, again, from this point on, all you'd have to write is the next step, and then you could subtract 1 in your head, and you get x is neg 5. Easy peasy. Okay. The next ones are exactly the same as what I just did with you, so look at that page. And what I want you to do is to add these lines here on your notes, because every time I'm trying to get
Like bases.
my bases to be the same. If you have a highlighter, highlighting those bases will help you remember. What I want to do is draw your attention to this guy right here. You see how you have 3 over 4 to the x power? And you go, gosh, that's a fraction, don't panic. The 3 can't be broken down anymore, so you just leave that. And what you do is you look at the other one and you say, oh, well, if it was flipped upside down, this is 3 squared over 4 squared, isn't it? Don't you agree? But because it's flipped upside down, it's got to be a negative. And that's all I did, is I said, ooh, this is just reverse of the 3 and the 4, so I'm going to make this a flip, and I'm going to make it a negative 2 instead of a positive 2. And then now I have like bases, x equals neg 2. The hardest part is getting to the line. And if you get stuck, email somebody, your new buddy that you're sitting next to, or somebody that you used to sit next to, and say, I'm number 4, for tonight's homework. What is your like basis? How did you get that? Those are the questions you ask. Your goal is to get like basis. Okay, next slide.
Who's gonna get like bases?
How to be a millionaire. Anybody want to be a millionaire? Me too.
I'll tell you.
My son wants to be a millionaire. I gave him this problem when he was like in 5th grade. He wanted to be a pro baseball player, and I said, you know your statistics of becoming a pro? Slim to none. Like 0.00001%, not even
More
close to
likely to be a slim
1%
man.
of every kid that's in the world wanting to be a pro ball player. He still brings this up to my face. He goes, Mom, it's all your fault. All right, professional ball players. Why he wanted to be a professional ball player? He's was born in 1987, and so this is around that time. This is 1990. This is when he brought it up to me that he wanted to be, as he was in Little League, hitting little balls on the tee tops. Anyway, that's another story. This is the problem I gave him. So this is from 1990. That's how many years ago it was, 34 years ago, that I gave him this problem. And I said, okay, if you want to be a baseball player, you know what you're going to make in 1990? That's, time is 0. So that's a 1. You know how much they made in 1990 for hitting a ball off of a pitch? $650,000 is what they made in 1990. That's for playing what? Professionally.
Hit the ball.
What, 5 months, 6 months? I worked not 12 months, a lot more hours. I don't go near that amount. I said, good profession to pick. So now you guys aren't in 1990 anymore. You guys are now in 2024. So how many years has it been since I gave this problem to my son?
34.
34 years. It's been 34 years. This problem has been in my lesson. What are they making now?
Millions.
Use your calculator. Plug in 650,000, because that's what they made in 1990 when I gave this problem to my son,
Probably what they make in TV.
times, they've got a 9% compound growth. 1.09 to the T power means that they're gonna make money on the money that they're it's like a double whammy. That's what their contract is. Mine at Pima is like, all right, don't wanna get there. All right, so what did you get?
12 million.
They're making 12 million now.
It's a shame.
You know why you can't afford tickets to the stadium anymore? My husband, he won't go anymore because it costs so much, and he goes, this is a ripoff. And then you go and park your car, and it's like $50 to park your car. This is a ripoff. He gets real mad. I go, go take my math class. This is what's happening. So that same ball player right now, that might be batting at a 33%, means 1 out of 3 times he does what he's been paid to do. That really irritates me. It's like me saying, okay, I'm only gonna come 1 out of 3 classes and you guys better pass. And they're still gonna pay me my $1,000. But a baseball player, his stats are, 33% would be a good baseball player.
He still has to show up, right?
He still shows up, but he only does what he's supposed to do 1 out of 3 times. And he's getting $12 million back. Tell me where the justice is in this world. See, I could really get into this. This is my favorite kind of stuff to teach. All right, so now we're gonna go to your pink sheet. When are you ever gonna use this stuff? Any of you have a college fund that you're going to school on right now? When my son was born, my parents gave me $1,000 for my kid. And I could choose to put it underneath the mattress, and when he turned 18 to go to college, he'd have $1,000. Or I could choose to invest it. Now, if you invest it at a bank, you're lucky to get .0005%
It'll inflate faster, probably.
on it. So what we do is we want to invest it somewhere where we get a little bit more money. The stocks, bigger investments. That's where you're gonna make your money, unless there's a crash. So, if I took his $1,000 and just put it in a bank that invested at 10%, he would have 71,000 when he turned 18. You're going, oh, that's not bad. Yeah,
Other banks that give 10% interest.
no. Okay. Will he have enough money to go to college or buy a new house when he turns 18 and he doesn't want to go to college? Could. Exponential functions is also done in medicine. Okay, again, I've already explained the medicine piece. Okay, can you become a millionaire in your lifetime? Look at the pink sheet. This is from my husband. He's a financial advisor. Or he used to be when he was a young guy. And yes, you can if you're 25 years old and you save $40 a week. That's like, going to McDonald's once a week. Don't go to McDonald's once a week and you'll probably save your 40 bucks. But it's saving $40 a week. So it's $160 a month. Can you be a millionaire by the time you're my age? Now, I did this when I was 67, so I'm a little older. But can I be a millionaire? What you have to do is get your employers to match, or you would need to be the boss to match in what's called an IRA. Do you guys know what that is? An investment that they're gonna match whatever you put in. So like here at Pima, they put in whatever I put in. So if I put in $100 a month, they're gonna match me.
401k.
Huh? 401k, yes. All right. How much will you have of that $1,200 if you can find somebody to do that? So why I'm telling you this is when you go looking for a job, before you just sign on the dotted line saying, yeah, I'll put in a savings account or I'll start my IRA or whatever, you want to try to negotiate to see if they'll match you, Now, is Burger King going to do this? Probably not. But when you start for your big job that while you're going to school, you want to think about this, that they can match your money. If you do that at age 25, you're going to have $4.7 million when you're my age. You guys know the rule of 72? You need to read on that pink sheet where it says the rule of 72. This was, I found very informative from my husband. Rule of 72. It tells you that it's an easy way to You invest your money for 9 years and you earn 8%. So let's say you go to the bank and say, here's $5,000. I want to know when I can get $10,000 to buy a new car. You say to the bank, what's your interest rate? They say it's 1%, that's going to be bad. But let's say they say it's 8%. Well, what you're going to do is you're going to divide the 8% into 72, and it'll tell you how many years that institution will take to double your money. So why am I telling you this? Because again, if you invest smartly and you don't just blow all your money in one big swoop, but you start saving it, you can earn some good money, but you've got to be, very conscientious and on the spot and ask your employer, talk to your employer, work with your employer, and ask them to match whatever you might put into your retirement account. It's a real big deal. You're going, I'm too young, no you're not. I taught 34 years in Illinois, and what I did in Illinois makes me now teaching in Arizona. I make a lot of money sitting on my butt. and you can sit on your butt, or you can still teach like I do, but the bottom line is, I'm not in it for the money, but the investment and how I invested when I was your age makes a difference. Okay, guys, you got a practice quiz, you got homework assignment, you know what you gotta do in a week and a half to get your best grade, that can really change your grade, right?
I can easily get my B back or have an F.
Wait, so explain this to me one more
Okay,
time. This
so-
is this my grade right now?
Yes, that's what you have right now, and, what, you're only able to get, 8 bonus points because your scores have been so high.
Okay.
So add all those together, and this is your best possible grade. If you turn in all the homeworks, get all the points on the quiz. This is the worst possible. You do nothing from here. You'll have 621 out of 770. If you do nothing right now,
And I want you to
you still
grab
get
it.
B.
I know it's gonna be a crap one. I know it's gonna be a
Now,
nice squish going like that.
That's your realistic one where you take a guess. I would personally, I would,
So the first thing we're gonna do is look to see if there's any
just for the
numbers
sake
over
of
here
easy math, I
that
would make that your average, or you could just guess. I'm like, okay, I'm gonna try really hard, I'm gonna get 85 at least on my final. I'm gonna get all the homework points, so I'm gonna miss 2 quiz points. And I messed up so bad on that exam, I could get up to 64 bonus points. So my realistic grade, maybe a little less than that, we'll see.
Okay,
Yeah.
now I need to
So
have
it's all out of
starting
77.
numbers somewhere.
And you see these at the bottom,
So what
right?
I'm gonna do is I take my
That would be your final grade
exponent,
in the class.
2x
You got that, right?
plus 3. Let me make it 4 plus 6.
I did so bad on that exam.
I had a point taken out from because I didn't like when I did the graph, I didn't put the arrow.
Arrow?
Yeah.
Oh, okay, I know what you're talking about.
I need to learn it.
Whatever this number is, we're gonna make 3. So I'm on a -2, -1, and -4, and 5. Now you're gonna put in these values, solve this problem. So 2 times 0 is 0. So it's
Just gotta find out what to do. Plus 6, plug that in your calculator, and then you just plot the points